now, we're being asked to find a cosine wave, and we're being given the attributes, but we're not given the equation. So we sort of have to reverse engineer the equation from these attributes. So again, remember the equation we're going to go for is a cosine bx plus c plus d, but we don't know what a, b, and c, and d are. We've got to figure them out from these attributes. So remember, amplitude is the absolute value of a, so we'll take a equals 2 to give ourselves amplitude 2. The period is 2 pi over b, and that's supposed to be equal to 3 pi. So from that we can figure out, if we solve that for b, we get b is equal to 2/3. So that's how we can figure out what b should be. The phase shift is negative c over b, which is supposed to be equal to pi over 2. Now, that requires a little bit of solving, so we get negative c over our b we already figured out was 2/3 is equal to pi over 2. So that's negative 3c over 2 is equal to pi over 2. The 2's cancel, and so we get c is equal to negative pi over 3. So that's how we figure out for what c is. We kind of reverse engineer this equation, negative c over b. And finally, the vertical shift is d, which is negative 2. So we figured out what a, b, c, and d are. That means that our equation is a is 2 cosine of 2/3 x minus pi over 3 minus 2. So we figured out the first part of the problem, which is to find the equation. Now we're going to do the tricky part, which is graphing it. But again, it's not so tricky if you start with a basic cosine wave, if you remember how to graph that, and then you introduce these attributes in the right order. So we'll start out with a basic cosine wave, cosine x. There's pi, 2 pi, 3 pi. Cosine x, I know it starts at 1. So there's 1, there's negative 1. It starts at 1, it goes down to 0. Bottoms out at negative 1, goes back up to 0, goes back up to 1. So now I've got cosine x. That I pretty much do from memory. Next, I'm going to introduce the amplitude. So I'm going to talk about 2 cosine x. That just stretches it vertically up and down. So that goes up to 2 and down to negative 2. Next, I'm going to adjust the period. So what I'm actually going to be graphing is 2 cosine of 2/3 x. Okay, I know that that makes the period 3 pi. Our original period was 2 pi, so this is stretching it out by, well, a factor of 50%. Instead of doing a full cycle in 2 pi, it's got to do a full cycle in 3 pi. So let me give myself some coordinates here. It's still going to start at 0, but it's going to bottom out now. Well, it's going to finish up at 3 pi instead of at 2 pi. and it's going to bottom out halfway between them, so that's at 3 pi over 2. So I took the graph and I stretched it out so that it has period 3 pi now. Phase shift, negative pi over 3. So what I'm going to be graphing is 2 cosine of 2/3 x minus pi over 3. Sorry, the phase shift is pi over 2. The c value is negative pi over 3, but the phase shift is pi over 2. So I'm going to take this graph and I'm going to move it over pi over 2 units to the right. So it looks like it's getting a little complicated now. I'm going to switch into red here. So we're going to graph the phase shift in red. So that means instead of starting at 0, I'm going to start at pi over 2. It's going to bottom out at 2 pi. And it's going to come back up at 3 pi plus pi over 2. So my orientation points were pi over 2 and 2 pi and 3 pi plus pi over 2 because I just took my orientation points before and moved them all over by pi over 2. So that incorporated the phase shift of pi over 2. So we're almost done here. We've got one more step to incorporate, which is this vertical shift of negative 2. I'm going to do this one in blue. So we're going to be graphing 2 cosine of 2/3 x minus pi over 3 minus 2. That means we're going to take the whole graph and just move it down 2 units. Now remember, before our peaks and valleys were at 2 and negative 2. We move that down by 2 units and the peaks and valleys are now going to be at 0 and negative 4. So I'm going to extend my axes down to negative 4. Negative 3, negative 4. And now I'm going to take my reference points from before and move them down by 2 units. So this graph peaks at 0, and it never actually goes north of the x-axis because it's going up to 0 and down to negative 4. So that's the final graph that we've been asked for. So let's recap there. We were given all these attributes: amplitude, period, phase shift, and vertical shift. We know the equations for those 4 things. Absolute value of A, 2 pi over B, negative C over B, and D. So what we do is we kind of plug in those attributes and reverse engineer to figure out what A, B, C, and D are, and then we can put those together to get the equation of the function that we're trying to graph. And then to actually graph it, we start with a basic cosine curve. We introduce the amplitude. Remember, it's very important to do these in order. Introduce the amplitude where you expand it up and down, so the thing actually stretches out. We introduce the period, which collapses it horizontally or stretches it out horizontally. In this case, we're changing the period from 2 pi to 3 pi, so that stretches it out horizontally. We introduce the phase shift, which moves it horizontally to the right or left without stretching it. The period was the part where you stretched it. The phase shift just moves it without stretching it. And then finally, we introduced the vertical shift, which moves it up and down without stretching it. In this case, it moved it down. So at the end of it, it's quite a complicated process, but individually, each one of these steps, if you keep them in order, isn't too hard. You just start with your original cosine graph and then move them around according to these steps until you get the one you want. So that's the end of our lecture on modified sine waves. This is educator.com.